Okay, guys. So here's the logic. So let's put something in your brain on how to calculate these things. So we are doing volume by common cross section, and you're gonna add up an infinite amount of them. So what's that logic? What are we talking about? So here is. So if I were to ask you, what's the volume of one sheet? Well, the volume is practically zero because it doesn't have any, I don't know, what word do you want to use? Girth or thickness or whatever you want to call it. It doesn't have any of that, right? But look, guys, if you start adding up all these cross sections, if you start adding them all up, look, all these cross, and I know all these cross sections have the same, it needs to be a common cross section. I know you don't need calculus for this one because they're all the same size and shape. If you start adding up a whole bunch, now it has volume. You don't need calculus for this. It's just length times width times height, and that will calculate the volume. So that's what this is. That's just showing that you're gonna find, I guess if you want to call it a slice, that's a common cross section. It has to maintain the same shape, and you're gonna add an infinite amount of them, and that creates the volume. Isn't that cool? So check it out. So that's all this is saying. So it's just saying it's a Riemann sum. Relax. We're not gonna go back to like Riemann equations and sum them up all at one at a time. We could, but we're not gonna go that route. So that's all this is saying. And then look what it's saying. It says volume is equal to the integral from a to b of the common cross sections added up infinitely. So here it is, common cross section. That's a slice, and you got to have that same common cross section. The size can be different, but the shape has to be the same. Chav, I have no idea what you're talking about. Okay, so check this out. So let's go right to the next page. Flip it, and hopefully we'll understand now. Hopefully. A mathematician has a paperweight made so that its base is the shape of the region between the x-axis and one arc of the curve y equals 2 sine x, linear units in inches. Each cross-section cut perpendicular to the x-axis and hence the xy plane is a semicircle whose diameter runs from the x-axis to the curve. And then it says, think of the cross-section as a semicircular fin sticking out of the plane. Find the volume of the paperweight. So, Chav, what are you talking about? And don't worry, you already see the visual down there. But this right here, this line, there's a semicircle coming out of it like that. And that line's a diameter. And it's coming out like that. So it's coming out of the board. So don't worry, I'm going to show you some free software. You're going to like it because that's like introduction to architecture type of thing. So here's the visual, right? So here it is. They're just showing you 1, 2, 3, 4, 5. They're just showing you 5 fins. But there's an infinite amount of them. So how does this look? You can download this software too if you want to play with it. I think it's so cool. It's called WinPlot. I found it through the University of Hawaii. If you went to the University of Hawaii, I feel like that would just be like a fun university, right? Because
it's so tough. I wish I applied there for like they
oh,
had a different application that I just didn't want to do. Like, I would love to do it.
I found this. If you're so, where did I find this software? At the University of Hawaii website. Just put WinPlot and look for University of Hawaii. Click on it, and or you don't need it if you don't want it. But I think it's pretty cool because I got to play with it. So here's that same problem. I already titled it. So check it out. So here it is. Let me maximize this. So that's the y equals 2 sine x. And then let me go ahead and do that visual for you guys. This is sections and there's semicircles. And I start at 0. So 0. And I go all the way to pi. And I think it's so powerful for what it does. So 0 to pi. And then check it out. See solid. And let me see if I can rotate it. Look, there it is. Let me go. Here's the plane, the xy plane. Do you see it right there down there? That's a plane, so that's the bottom of it. And let's see if I can make it flat. Here's how it looks. Now you gotta have a pretty strong computer because if your computer is not strong enough, it doesn't have enough RAM, it's gonna it's not gonna do it this clean. But if you have a strong enough processor, it should be able to handle that. You don't think that's cool, guys? I think it's really cool. And you can play with it, it's free. Download it at University of Hawaii, WinPlot, and then just start messing with it so you can visualize it. If you don't have to do this, this is just to visualize. I thought that was so cool. I thought about doing a project of just that, but I'm like, wait, we don't have time. So maybe after the AP exam, if you guys want to mess with it, we can like do a lab on that or something. So yeah, so there it is. That's how it looks. Oh, yeah, are you guys not impressed? I thought that was cool. All right, let's figure out that volume. So what is this cross section? So first, let's figure out the cross section, the A of x. So A of x, my cross section. So I want to figure out the area of one of these semicircles. So side note here on the side, area of a circle is pi r squared. So area of a semicircle is pi r squared divided by 2. Yay or no? Yay or nay? Yeah. The pi r squared divided by 2, that's a semicircle, right, guys? Okay. Next, I want to figure out, well, what am I going to do? Here's the diameter in red. This is the radius. This is the radius in blue. So how do I figure out what the radius is? So here it is. Here we go, guys. Pi, giant parenthesis. The radius is the diameter divided by 2. So how do I figure out the diameter? Well, the diameter is just a curve. How do I figure out the diameter of at any point at any x value? The diameter is just that curve, 2 sine x. You guys see that? So I'm going to type in there 2 sine x. That's the diameter, because that's going to tell me my diameter. And I'm going to divide that sucker by 2, close it, put a square on it. And right now, that's just my area of a circle. And I divide all that by 2 again. So there it is. That's my cross section. The 2's cancel out. My a of x is pi sine squared x divided by 2. I guess you can say pi over 2. And then here's my volume equation. Volume equals integral from 0 to pi, because there it is. That's a 0 and that's a pi, of this guy. Pi sine squared x over 2. I think the software gives you an approximate volume. I'm going to type this into my calculator, and I'm going to put the answer. Here's my calculator. Let's see, math number 9, 0 to pi. Make sure you're in radian mode, 0 to pi. And you can put the pi over 2 on the outside, or you can put it on the inside. It doesn't matter. Pi over 2 times parentheses sine x close squared, and then put an x. Hopefully, if I didn't make any mistakes, there it is, 2.467. 2.467. Let me look at that software again and see if it gives me an approximation. What was it? WinPlot? Okay, it was this guy. So close 2 sections, semicircle, low of 0, high of pi, pi. See solid. And there's my solid. Volume equals. There it is, guys. Check it out. It does work. I don't know if you can see it. Is it too small in there? It does work. It says volume equals 2.467. So I think that's really cool. I think it's really cool that this, and this is just the beginning, right? For those of you that are going to be engineers, there's AutoCAD that tells you, like, if you enter the density of the material, it'll tell you how much it's going to weigh and all that good stuff. So it was just the beginning. You're just scratching the surface, but you can hopefully start seeing like the usefulness of calculus and all that good stuff. So I think that's so cool. And then we're going to do even cooler ones tomorrow when we come back. Oh, check it out. Look at this. Okay, let's look at, let's see if you guys can make a connection to real world. I'm thinking of one thing right off the bat that I see it. All right, example 2. For A through D, find a formula for the area A of X, so that's what we're adding up, infinite amount, a common cross-section of the solid that are perpendicular to the x-axis. The solid lies between the planes perpendicular to the x-axis at 0 and x equals 4. The cross-sections perpendicular to the x-axis between these planes run from y equals negative square root of x to square root of x. The cross-sections are circular discs with diameters in the xy plane. Okay, so here it is. So visually, I know, guys, I know it's kind of hard to see it visually, but look at this. So look at this guy. You have an infinite amount of circles, quote unquote. Disc is what the mathematical term. Can you think of something in the real world that mimics this? I'm thinking of one thing. Oh yeah, the tip of a rocket. I was thinking of an airplane. The nose of the airplane. This could be used to model a nose of an airplane. Isn't that cool? I think that's cool. All right, guys, here we go. So the cross sections are circular discs with diameters in the xy plane. So right now, what are we trying to do? We're trying to figure out an equation, A of x. So this top part here is y equals square root of x. And this one right here that goes below the x-axis is y equals negative square root of x. I guess in conic sections, you can also say that's the same thing as x equals y squared, right? So the diameter of that circle, well, I guess first let me just tell you in general. Side note, area of a circle area of a circle, and in the math they call it disk, is pi r squared. The radius is the distance from here all the way to here. I'm looking at this one circle, and there's your slices. They're just showing 3 slices. Boom, boom, boom. So the area of that circle is pi, and then the radius. Well, the radius is just the distance from the x-axis to that curve, and that curve is square root of x. So pi square root of x, close it, squared. Done. Is that all they wanted? Okay. If you wanted the volume, they're not asking for it. But if you wanted the volume, you would go volume equals integral from 0 to 4 of this guy. Pi square root of x closes squared dx. And I know the square root of x squared is just x. This is just a constant, so if you want, you can pull it on the outside. And whatever the calculator gives you, that's the answer. Right now, I'm not necessarily interested in the calculator, guys, because I'm more interested in can you set it up. And that's it. So what are you integrating? A common cross-section. And then you're just adding them all up. Does that make sense, guys? Okay, letter B. The cross-sections are squares with bases in the xy plane. So all we're doing is finding an area formula. The distance from here, first, what's the area of a square? Side note, area of a square with side, quote unquote, s is s squared. Okay, so what's the area? My whole side is this in blue. So you can do one of two things. You can either go the distance from the x-axis to the top of that curve and then multiply it by 2. Or you can do top minus bottom. You're going to get the same answer. So here it is. What's my side? I can go 2 times square root of x. So 2 square root of x. You would have also gotten that answer if you would have done top minus bottom. Square root of x minus negative square root of x. See? Top minus bottom. And look, you get the same answer. 2 square root of x. If you want the volume, they're not asking. But if you wanted the volume, you would go volume equals integral 0 to 4 of 2 square root of x dx. Because you're adding up an infinite amount of cross sections. Don't worry, Delta's going to have a super awesome animation. I'm going to show you. I can't wait. This is one of my favorite Delta lessons because the animations are so awesome. How do we feel, guys? Do we feel okay? Okay. The cross sections are squares with diagonals in the xy plane. So now they don't show you a picture. So imagine this square. You know what? Here's how I would do it. So here's my xy plane in 2 dimensions. And here is the y equals square root of x, or x equals y squared. And then this cross section right here, that's the diagonal of a square. So, Chav, what are you talking about? Here's my square. Let me draw it in red. My square sucks. And here's my diagonal. It's going right through the center of that. So imagine it's coming out of the board. It's coming out of the board, and it has spikes. It has spikes. And the biggest one is right over here at 4. And then as you get closer to the origin, it gets smaller and smaller.
On both sides?
What do you mean?
Spikes on both sides?
Yes. One coming out of the board and then on the other side of the board. Yes. Ooh, spikes on both sides. Yes, yes, yes. It's not enough. All right. Here we go, guys. Ready? Here we go. This length, so right now, what do we know? That's S, so area of that is just S squared. But I don't want, it's not in terms of that S. I want it in terms of this diagonal here. So think about it. The distance of that diagonal, I'll wait. I want to make sure we're good. All right. And do you guys see this triangle? I'm just going to label it ABC. Don't write any of this because I just want you guys to take this in. So in a right triangle, there's a 45, 45, 90 triangle. In a 45, 45, 90, you have n square root of 2. Correct? Okay. The distance from the x-axis to this curve, well, I guess that total distance is, this total distance here is 2 square root of x. We already know that. So that's this guy right here, this total distance. But I don't want that. I want that side. I guess you can label A and B, A and A, right? So I want A. So here's what we're going to do. You're going to go, I guess you can use this right here. So A, and A squared of 2. So 2A, so A, what am I going to do? Oh, yeah. So 2 squared of X, 2 squared of X equals A squared of 2, equals this guy. And I just want A. So you just divide by square root of 2. I'm trying to find the side length. Does that make sense? And then, so there it is. That's my side length. So 2 square root of X over square root of 2. Leave it alone because what are we going to do with that length? We're going to square it because area of a square is side squared. Does that make sense? So here it is. So what's my answer then? Your A of X is 2 square root of X over square root of 2 squared, which simplifies, let's see, what did that simplify? 4x over 2, so 2x. So if I wanted the volume of this, do I have space? Volume equals integral from 0 to 4 of 2x dx. Yeah, maybe I confused you guys because I was going too fast. I was labeling sides. I called it first S squared, and then I called it A. Maybe I should have called it S. So sorry, guys, if I confused you. So let me stop because I want to make sure that we know what we just did. Because some of you look like, maybe it might be my fault. I called it A instead of S. I'm trying to figure out how to get area of this square here, guys. Remember, area of a square is just side squared. So I'm looking for whatever A is, and then whatever A is, I'm going to square it. I know the diagonal. Chop, how do you know the diagonal? This is the diagonal. That diagonal, the distance from here to here, that's 2 squared of X. Upper minus lower, or whatever this distance is, times 2. Does that make sense? So then I said, okay, well, it's a 45, 45, 90 triangle. I already know the diagonal. So the diagonal is 2 square root of X, and that equals my A squared of 2. What you're trying to find is A, one of the sides. So divide by square root of 2, divide by square root of 2. There it is, that's my side. So that's what I'm squaring. That's squared. See? So 2 squared of X over square root of 2 squared. 2 squared is 4. Square root of X times square root of X is X. Square root of 2 squared is 2. 4 divided by 2 is 2. So 2x. Does that make sense, guys? Okay, yeah, stop me. Sometimes I can tell when you guys are totally lost, like right there. But hopefully it made sense now. What's up? From the distance of the diagonal. That's the distance from, that's this line right here. If I want to figure out the length, remember this is the square root of X and this is the square root of X, negative square root of X. So I can either go square root of X times 2 to get or you can do upper minus lower. Square root of X minus a negative square root of X, 2 square root of X. It doesn't matter how you do it, the logic is going to be the same. Does that make sense? Okay, ask me, guys. Dime. We're good? Okay. Whew, that was tough. The cross sections are equilateral triangles with bases in the XY plane. Ooh. All right, let's see if we can do that. So I'm going to draw the same thing again. Let's see if we can do that. Oh, let me stop it at 4 instead of. All right, so here's 4. And here's my base. So that line that I'm drawing, I'll do it in blue. That line that I'm drawing is the base. So it's this part. There it is. And then let me draw my triangle. Yeah, it's an equilateral triangle. So this line is this of my cross section. Cool? And it's coming out of the board. Spikes on the top. A cross section equilateral triangle with bases in the XY plane. Yep. Got it. Okay. This line in blue, that length is 2 square root of X. Hopefully, and if you don't, that's fine. You either remember how to find area of any triangle, AB sine C, I think is what it was, or you can just do it by hand. If you cut this equilateral triangle right down the middle, you create a 30, 60, 90, right? This is 30 degrees right here. That's 60 degrees. Here's 90 degrees. And in a 30, 60, 90 triangle, you have n square root of 3, and 2n. I'm just trying to, Chop, why are you doing that? Area of a triangle is 1/2 base times height. I already know the base. The base is this guy. I need to figure out the height of that cross section. See? Are you guys following with me? Yeah. Ask me, guys. Ask me questions. So I'm trying to figure out the area of this equilateral triangle, guys. So I already know my base is 2 squared of x. So area is 1/2 times 2 squared of x. And I need to figure out the height. Well, according to this is my long leg. My height is whatever my short leg is times square root of 3. My short leg is this distance in green. That green is just square root of x. Yes or no? So square root of x times square root of 3. So square root of x times square root of 3. That's just square root of 3x. Law of exponents. I just took the n, which is square root of x, and I multiplied it by the long leg, square root of 3. So there it is. So 1/2 2 square root of x times square root of 3x. And I guess if you're using law of exponents, you can say, let's see, 1/2 and 2 cancel out. Bam, bam. And you can go area equals square root of 3x squared. 1/2 base times height. And if you were to do volume, they're not asking, but if you were to do the volume, it would be integral from 0 to 4 of square root of 3x squared dx. I don't see an issue. I think we're good. Let me see. Base, 1/2 base. Base is 2 squared of x. The height is square root of x times square root of 3. So square root of 3. Yeah, everything looks good to me, guys. Cool or not cool? That's what's hard, guys. Just creating a model. All right. Last question. This is from the 2008 AP exam. It says, let R be the region bounded. Let's see, calculator required. So you're going to need a calculator. Let R be the region bounded by the graphs y equals sine pi x and y equals x cubed minus 4x, as shown in the figure to the right. Find the area of R. All right, look, guys, how they don't give the functions names. Chop, what do you mean by names? Sometimes they call one f, one g, but this time they don't. If they don't call the functions names, then you got to use this in your integrand. Upper minus lower. Chop, I can't tell which one's the x cubed minus 4x and which one's the sine pi x. Can you guys tell which one? You have a calculator anyways, but hopefully we're able to tell. Let's see. This curve right here, the one on the top, take a guess. Which one do you think that one is? Yeah, that's the sine pi x. The x cubed minus 4x is this one down here. So check it out. Take your calculator. I would make sure, I would type those into y1 and y2 right off the bat. What was it? Sine pi x? Sine pi x. And what was my y2? X cubed minus 4x. So just remember where you put them, guys. I didn't put a minus. And then I put 2 4s. What the heck? All right. And then I'm going to make my window look like this. So how do you make it look like that? I'm going to go X. I'm going to click window and then 0 to a little bit bigger than 2, 2.2 or something. So window 0 to like, let me, 2.2. I guess I could also go negative 0.2. Yeah, let me, negative 0.2. X go by 1. Your Y values, let's see, negative 3.5 to 1.5. Negative 3.2 to 1.2. And then when I graph, I put X scale 1, 1.2. And then when I graph, hopefully it looks more or less. Yeah, it does. It looks more or less. See? The one in the blue is your sinusoid. See? Blue. And the one in the red is your power function, the cubic. Cool or not cool? Okay. So check it out. You don't, and do not, on any exam, do not use calculator notation. This is just for you. This is just for the notes. So find the area of R. Sometimes this is just worth a point, just alone, guys. So get your free points. Area of R, you're going to go R equals integral. What are my limits? 0 to what? To 2. Which one's on top? sine pi x, close it, minus, which one's on bottom? Put a parenthesis, x cubed minus 4x, close, and then put a dx. If you want to put a giant parenthesis around the whole thing, boom, boom, you can if you want. You'll have pens. You can have a blue pen and a red pen, or a blue pen and a black pen, and you can use blue and black back and forth if you want. That's fine. You don't need those blue parentheses. It's understood that the dx is the end. Are we cool? All right, so here it is, guys. You don't have to show. Oh, by the way, on the calculator section, if it's a calculator section, they don't want to know if you can do the antiderivative by hand. You just got to show. This is called, quote unquote, the setup. So some of you, when we took the first mock exam, you were doing everything by hand on the calculator section. On the calculator section, you just got to show the setup and then just give me the answer. Does that make sense? If this were in the non-calculator section, then yeah, they want to see if you know the antiderivative. But it's a calculator section, so just show the setup and just give them the answer. Cool or not cool? Okay, so here it is. Here's my answer. Equals. And I'm just going to type it in the calculator. All right, guys, and you already have this. This is just for notes. You already have this in Y1. You already have this in Y2. Do not use calculator language on any exam, guys. Cool or not cool? So here we go. Take my calculator. I'm going to go second quit. I'm going to go to the home screen. I'm going to go math 9, 0 to 2. And then I'm just going to go Y1, alpha trace, Y1, minus alpha trace, Y2. Put an X on it and push enter. I got a perfect number. Did you guys get a perfect number? So there it is, 4. We'll look at the rubric in a little bit. Made me a little sus, but yeah, that's fine. How do we feel? Okay. Letter B, the horizontal line y equals -2 splits the region R into 2 parts. Write, but do not evaluate, an integral expression for the area of the part R that is below the horizontal line. Okay, take your pen or whatever it is and go to y equals -2 and just draw the line. See? The horizontal line splits R into 2 parts, right? But don't about an integral expression for the area of the part R that is below. Okay, they want this. They want this right here, below that line. So what do I need? I need to find where they intersect. So you need to type this into the calculator. So go to the calculator and go y equals and go to Y3 and put -2. Push graph. And you're going to need to find these intersections. So I'm going to go second calculate number 5. And then, nope, it says first curve. I don't want the blue curve. I want the red curve. So go to the red one. Enter, first curve. Second curve, that black one, yes, enter. And then guess, scroll to the one on the left first and push enter. 0.5391889, that's what I'm going to use. So I'm going to come over here and I'm going to say, I'm going to call this, what am I going to call it? I'm kind of tempted to call it a, no, I'll just say, okay, here's what I'm going to do, guys. I'm going to go, that's the x cubed. I'm going to go x cubed minus 4x equals -2. That's called the setup. And I'm just going to give the values of where that happens. When x equals, and then what is that number? Put all the digits. 0.5391889. 0.5391889. Put an arrow. I'm going to store that in A, or equals A. And that's what I'm going to do right now. That's what I'm going to do right now. That intersection, I'm going to go to my home screen. I'm going to push X, store alpha A, and I'm going to make sure it's the same digits, 0.5391888. All right, now I'm going to get the other one. Second, calculate number 5. Nope, not the blue line, the red one. Enter, enter, and then scroll. When it says guess, if you don't move it to the right, it's going to give you the same number again. Scroll to the right one. Boop. 1.6751. So I'm going to go down here, and I'm going to say x equals, I already forgot it. 1.6751. 1.6751. Give me all the other digits. I don't remember. Did you guys do it? What is it? 300? 3087. Store that too. What do you think I'm gonna do? What letter? I just go down the alphabet, guys. Store that to B. So here it is. Now that you make sure that you write this on your exam, on any exam. So this is called a setup, and you're just giving me the x values where this is true. So there it is. This is my lower limit. This is my upper limit. Now you can use the letter A and B all you want. So I'm going to go, this area is the inner area from A to B. And then what curves on top? It's this red line. What's that red line? Negative what? Negative 2 minus parenthesis. What is that curve? X cubed minus 4x. Close it. Put a dx. Did they want you to solve it? No, you're done. We'll look at the rubric. I have yet to look at the, obviously I looked at it sometime last year, but I have not looked at it all this year. So let's see how far or how close we are to it. All right, letter C. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume of this solid. Okay, so let me erase this. So now look, guys, this part right here, that region, you have a square coming out. It's coming out of the board. It's coming out. So all I gotta do to find the cross section or to find my volume is find my cross section, the area cross section. Well, one of the sides is this. That's one of the sides of the square, and then the other side is coming out of that square. So just draw perpendicular to the x-axis, guys. Draw this. So look, this, boom, that is a cross section, and what is that line? It's this line from the square. So it's that one, and it's coming out of the board. And there's a whole bunch of them, an infinite amount of cross sections coming out. So what do? Do they want me to find? Yeah, they want me to find the volume. Okay, volume equals my limits from what to what? 0 to 2. Good job. 0 to 2. And then I just find my area cross section. Upper minus lower. And then how do I find area of a square? Side squared. So upper minus lower is going to tell me the length of that side. And then I just square it. So open parenthesis, upper, so sine pi x, minus, if you want to open another parenthesis, go for it. And then I'm going to, just like this one, x cubed minus 4x, close, and then close. Let me use different colors here. That big one, and then there it is. That's one of my sides. That's just a side. What do I got to do to get the area of that square? Square it. So there it is. That's my area cross section. And then don't forget the dx. And there it is. That's it. And then we just type it into the calculator. So here's my calculator. Let's go with our calculator again. Come on, buddy. Calculator. So here we go. Second quit. I'm going to clear this. I'm going to go math 9. I'm going to go 0 to 2 again because it looks like those are my same limits. And I'm going to open up a parenthesis. And I'm going to go alpha trace y1 minus alpha trace y2. Close it and then put a square on it. And then that's it. We're done. X. Boom. 9.9783. 9.9783. 9.9783. The more digits, the better. How do we feel, guys? Okay. And then the last one here. I don't know. I put in there we might not be ready for this one yet because you don't have enough experience. This is your first rodeo, but it's the same logic. So let's see if we can do it. The region R models the surface of a small pond. So now imagine that's a small pond surface at all points. So you're a bird. You're a bird. This is the surface of a small pond. At all points R, the distance x from the y-axis, the depth of the water is given by h of x is 3 minus x. Find the volume of water in the pond. Okay. So when I do a cross section, so guys, read it again, just in case you don't understand. They tell me that from this, the depth of the water is, was it 3 minus x? H of x equals 3 minus x. So one of these cross sections is the shape of a rectangle. It's whatever this size is times whatever the depth is. Do you guys see that? And all of them are rectangles. Boom, 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 boom. So how do I find the A of x, my cross section? So let's just do the cross section first. My A of x. My A of x is upper minus lower. So it's going to be, let's see, what was my upper curve? Sine pi x. Minus, and my lower curve is x cubed minus 4x. x cubed minus 4x, close, and then close. Let me put big parentheses. So that right there is the height or the width of one cross section. Now I got to get my height of that one cross section. So the height is just the depth. Do you guys see that? So all that times, and here's my next one, 3 minus x. That's my cross section. And all points are the distance from the x-axis of the decimal water is given by, find the volume of the water in the pond. Okay, I think we're good. So here's my volume. Volume equals integral 0 to 2. Put this one in first. Or I guess you could also call it a of x because you already called it a of x. But I would just type in everything. Sine pi x minus x cubed minus 4x close times 3 minus x. Make sure to put the dx because that's understood to be the end. Chav, I don't understand today's lesson. All you're doing is adding up cross sections. That's all you're doing, adding up infinite amount of areas to create volume. All right, so let's take the calculator again. I'm going to go math 9, 0 to 2. And then I'm going to go parenthesis alpha trace y1 minus alpha trace y2. And then close the parenthesis right there. And then open another one. And then for that one, you're going to type in, I already forgot, 3 minus x. You're going to type in 3 minus x. 3 minus x. And there it is. Did I close the parenthesis? No, I didn't. Close. And now we're good. Put x here and enter. 8.3699. That's what I got. Is that what you got? Volume equals 8.3699. All right, let's look at this rubric and see how we did. This one was 2008. Okay. So here's the rubric, guys. San Antonio, Math Life, Calculus, College Board, Response, AB, Scoring Guidelines, 2008. All right, here we go. All right, let's see. All 3 response questions are worth how many points? Do you remember? 9. Did we get the 3 points for letter A? How many points was letter A? 3. And look, we got them all. They give you 1 point for the limits, 1 point for the integrand. Wow, I can't believe they did limits and integrand. Usually those are 2 or together. And 1 point for the answer. And we got them all. Cool, right? All right, letter B. Why did they use the letter R and S? That's weird. Whatever. I don't know why they used the letter R and S, and I just go down the alphabet. They said they did the setup, and then I called RA and I called SB. We got the full credit. Limits and integrand. Yep, we did it exactly how they did it. Letter C. There it is. Sine pi x minus x cubed minus 4x. Upper minus lower squared. 0 to 2, 9.978. We got both points. And then the last one, there it is. They put the 3 minus x in the front. Did we get 3.69, 8.369, or 8.370? I don't remember what I put. Yeah, 3699. Yeah, look, you could have rounded it, and they would have given you the point. Isn't that cool, guys? Does this make sense? Hopefully, was this lesson good? Like, did we get it down on okay. All right, guys, so that's it. Let's just perfect our craft. So log into Delta, and you will need your calculator, and that's all you're doing. Common cross sections, finding the volume.